started. Thanks everybody for joining. We're very excited to present you the service chains today and a great innovation we bring to the data spaces. So on the agenda, I will start with an overall introduction on data spaces, relationship with AI, and what we do in Prometheus-X. I'm the president of Prometheus-X and the CEO of Visions. Felix will then do a demo of such a service chain inside one of the data space providers, Visions. Felix is the CTO of Visions, and then we'll have a technical deep dive on how these chains actually work. And we will finish with Laszlo, which is the head of a department at the Budapest University for Mechanical Engineering, that will tell us about other components, building blocks that are coming, and so on. And of course, let's be as interactive as possible. So we'll ask your questions in the chat or raise your hand. We'll have some pause after the different parts to see if there are some questions attached to it. So if we now, everybody of course is talking about AI, how to deploy AI agents to automate tasks, to build new kind of products. And this supposes to integrate with different databases, with different systems. And these systems can be internal, they can be external to the organization deploying the agents, so that then you can do some analytics, some actions, and create this new era of AI. And that's where data spaces come in, because this integration with each and a huge number of systems take time and money. Time and money from a technical level, where you need to integrate with each API, each system, and from a legal level as well, where you need to negotiate every time a separate agreement with different processes and different ways of validating these agreements and so on. So this takes a lot of time and money, and that's where data spaces come in to, in a sense, provide a technological and legal protocol and infrastructure to standardize and automate that and reduce this to zero, so as to be able to much more quickly integrate with a vast variety of systems, of databases, and deploy a new kind of use cases. So Prometheus-X, that's what we provide, is to provide open source components for data spaces. There are about 19 partners that develop these components. We have today about 150 use cases from 700 organizations that build these use cases and that provide data and services in different domains. So skills, media, smart cities, legal, and others. And so we are proposing this open source infrastructure to be able to deploy data spaces and this kind of innovations. We've been co-funded in a sense by the European Commission and by the French government. On a general aspect of the architecture, so on the top you have the different AI, the different databases, the different systems that needs to be integrated. On the bottom, you have different specifications coming from organizations like GaiaX, like IDSA, the Data Space Support Center, that kind of specify how a data space works, how to describe your services, how do you check a contract, what is in that contract, how does the protocol work, and so on. And so Prometheus-X provides an open source implementation to put that into place and offer organizations ways to more easily connect to data spaces and enable such a, in a sense, standardized and common network. But Prometheus-X does not operate this as a service. It's not a platform. It's really the open source code, the common, in a sense, community to develop it and the governance of that. And then we have data space services on top. So coming from organizations, usually also the ones that contribute to the stack, that can offer it as a service. And you have a list of some of those on the right that provide this as a service so that the different participants can more easily connect, of course, each and everybody is free to access the open source code. So with that, and these different components, how does it relate to, in a sense, existing standards and other implementations of data spaces that exist? So what we aim to do in Prometheus-X is, of course, respect all the official, in a sense, data space specifications and enable interoperability and federation with any other data space stack or solution that exists. So here we've listed a few. There is, of course, the data space protocol, of which we are interoperable with and integrate since February, and that facilitates, in a sense, interoperability with other connectors, such as DSP-based connectors or the Eclipse connector. Gaia-X describes ways to describe, in a sense, offers and services and organizations. So we integrate that, and we are integrating as well the trust framework and the clearing houses for an implementation by autumn, more or less. Fireware has also a data space connector, and so we have a partnership and agreement with Fireware, and we're enabling this interoperability by July. And of course, Simple, which is the open source implementation of the European Commission that is still ongoing, but we are now federating the catalogs and the interoperability there, and we aim to have a first implementation there by June. So the general aspect here is to enable as much is an interoperability as we can, federation with other stacks, so that anybody using Prometheus-X doesn't need to implement other stuff to integrate with others. And of course, we add some cool components on top of all of that, such as the service chains. So on the service chains, what's the concept is to say that usually in a data space, as I introduced a bit with AI, it's rarely about just transferring a data set from A to B. It's mostly going to be about data comes from A, goes to B, maybe B transforms it, sends it to C, that adds some data analytics on top of it, then it can be accessed by some LLM agent to do some transformations on it, and then do an action to D. And so we see that we need to manage this kind of sequences of between different data space participants so that this kind of use cases and this kind of implementations can work. And that's really what the service chains are about, to manage on a technical and legal level this kind of sequences and in an easy way for participants. So Prometheus-X, we enable that through different components. We'll get into more demos and details later, but basically a catalog where you can find all the data, the services, the projects on the network, ways to contract and negotiate with the different participants, ways to handle GDPR consents for individuals, additional components on interoperability, anonymization, and so on, and a connector that allows, in a sense, each participant to receive and emit requests and check the validity of requests, and also enable the service chains, as we will see. And so one example here, not going into all the full details, but an example coming from the education data space is here with the French Ministry of Education deploying, let's say, learning assistant for pupils that will generate personalized exercises, learning cards based on the pupil's level. And so to do that, you need the LLM that will generate this kind of exercises, but you need data about the pupil. This data is stored in other systems, in the school systems, in some education technologies that the pupil uses that can inform on their level on a given topic. And you need data about learning content so that what is generated is, in a sense, compliant with national programs, but also is pedagogically relevant. And this data is also stored in learning management systems and also protected as personal data, but by copyright elements and so on. And so here in this use case, different providers of search data are connected, and their data can flow to a personal data store, and the LLM can use it to generate this kind of exercises. Then we can see here that there needs to be a certain sequence of exchanges between these different providers to enable the use case. And that's why the service chain is, for instance, needed. Another case is of another use case in the skills data space. Here is a bit more technical representation, but it's of a participant wanting to enable a service where it will give access in a secure environment of anonymized data sets so that model providers, other AI applications can train their models on top of it. So you have on the left side some providers of such data that are connected to the data space. This data is not yet anonymized, so it needs to flow through an anonymized service also connected to the data space, and then go to this, in a sense, secure processing environment so that others can start using and deploying their algorithms on these anonymized data sets. Then again, you need to combine different participants, different services, data providers together to enable this kind of flow. And that's what the service chains are for, is to enable this kind of multi-party sequences. And as a provider, you don't need to do a specific integration for each project you're involved in. You connect once, thanks to the connector, and then the connector manages the complexity of the service chains. And this allows for more quicker, easier, less costly data consumption, and of course, always keeping track of who has access to what, who needs to retribute who, and so on. So I think this is quite new in the data space world, and this provides something very useful, and we're happy to present it to you in more details today. Hope you'll have a lot of questions and a lot of interest. So I'll pass the floor now to Felix for a more concrete demo and deep dive in how it works. But if you have any kind of question about what I presented, please feel free to raise a hand or put it in the chat. So, okay, I'll pass the floor to Felix. That will show an implementation of these components integrated in the VisionsTrust Dataspace service that can show a bit more functionally how it works before we go into the technical details. Thank you,
Great.
Felix.
Thank you, Matthias. All right, so yes, I'm going to showcase a little bit how it works, how all of this works inside the VisionsTrust catalog. I'll get into details later, but the VisionsTrust catalog is also encompassing other services such as the contract service, a consent service, and a registry, which are different components that Prometheus-X is building. So showcasing a little bit what we can do in this catalog. I'm logged in here in a dev catalog just to mess around a little bit without breaking anything on the production environment. But so you, as a participant of the data space, come in and onboard yourself inside of a data space through this catalog, and VisionsTrust is one of them. You're going to be creating an account, registering your organization, defining who you are. And once you do that, you become an official participant of the ecosystem, and in this case, of the Prometheus-X ecosystem. Inside the catalog, so you have, of course, all of the discovery services where you can find other participants, other organizations, what kind of offers others provide, what kinds of projects, and we'll get into our projects later, they can provide, and what kind of infrastructure services they can provide. So you have discovery functionalities, filtering functionalities that allow you to kind of browse around and find things that might be of interest for you as a participant of the data space, and then go inside and get more information, try and see if you can use them, enter negotiation processes, etc. But so how do you go in and create a specific offer to publish it on the catalog? First off, offers, the concept of an offer is taken from the Gaia-X trust framework's schema definition. So they represent service offerings, which are a composition of different resources, one or more specific resources. And a resource is actually an asset, so some kind of data set, some kind of API that you can provide as a participant to others inside of the network. So essentially, when I'm going to be creating some kind of offer to provide on the catalog, I'm first going to be declaring a resource. Here I have some example ones. I have, for example, here the learning traces, which represents a data set of learning traces I can have and propose to others, where I'm going to specify some basic information that's going to be available for others to browse. So that the name, what type of resource it's allocated to have some categorization purposes, a description of it. So really some metadata, generic metadata on it, but also some more, and we'll get into this afterwards, technical metadata that will be able will enable, the connector then to run all of these processes for the data exchange processes later down the line. So create your resource, and then you want to bundle them up, one or more, inside an offer. So you can create an offer, and when you do so, same thing as for the resources, you're going to be able to specify some metadata information on your offer, so your package that you're publishing to the catalog, what the different contents are. So for example, here I have a learning record storage service. I have a software resource that is actually this API of learning record storage. I've defined a certain pricing for it. I've defined certain policies for it, and policies here imply data access policies based on the contracts that will be used for data exchange. Same as for the rest, I'll go into this in more detail later on, but basically these are ODRL policies that are going to be injected in the contract that are able to define some specific constraints on the access of data during the data requests and the inside the data exchange protocol. So you define all this information, and once you do so and you decide to make it available, you can publish it to the catalog, and it becomes available for others to browse and negotiate on within the catalog itself. So this is for offers. The other important entity that we have inside of VisionsTrust are projects. And so projects are based on the Dataspace use case definition inside the DSSC, which Prometheus-X pushed into the DSSC. And so they represent some kind of data space of a specific set of partners that work together in forming a specific use case. And the advantage of this, there are multiple, but one of the biggest advantage of this is that they can set up some data exchanges between the members of the project without needing individual contracts and one individual one-to-one agreements between each and every member of the use case. So if we take a look here, I've created one in advance to gain some time, but the representation of one of the use case matches was talking about before, the Wally use case, which is led by one of the partners, Inokufu. They can here have a list of participants that they've invited to the project, and how they've done that is basically by going into the catalog, browsing the offers of others, finding offers that are relevant for their catalog, entering a negotiation process to say, hey, I'm interested in your offer. I think it could be used in this specific project that I have. Would you be interested to join? Enters a negotiation loop where they define the terms and the specific pricing and policies that apply for the context of this project. And then once this negotiation loop is done, the partner actually becomes part of this project and is able to interact with it. So these participants that you see here, so there are some demo participants, but you can see we have Games for the Citizens, the Platform Push here. We have different participants that have gone through this process of, I have invited them, they have agreed, and they are proposing specific offers for the context of this project. If I look into the contract real quick, so it's the same kind of information we find on the page before, but we see basically exactly what specific offers each participant is providing. And this allows you to see also that there's some sort of granularity on what each participant can provide in each project. When I invite someone to my projects, say I invite Games for Citizens, I'm inviting them for a specific set of offers that they provide to the catalog, but not all of them if I don't need all of them. So here, Games for Citizens is only providing a data set of learning records for the context of this project. So you can build around your project like this quite easily. There's a lot of different settings you can apply to it. And as you've seen, this catalog here is all about metadata on the assets, metadata on the use cases. So having all of this information also allows us to provide some matching capabilities for helping project leaders and also offer providers to discover one another. So here, for example, in my project settings, I said that I'm interested in data sets that represent hard skills. This is one of the categories that we have inside the catalog. And through the matching offers tab, I can see a set of different available offers that fit this specific things that I'm looking for my project. So we have these matching capabilities that help in building the use case, help orchestrators find the offerings and resources that they need for their projects, and yeah, have an easier time in building all of this. Okay, so these are the two basic entities that are really important in the catalog, the offers and the projects. Now, when we talk about projects, so you understood that these are a group of participants that work together under a single contract. This also provides the infrastructure, if we want, to build out what we call these service chains. And so the fact that we have one single contract for authorizing the different data exchanges within this project allows us to build some more complicated workflows in order to build sequences of data transfers between the different parties of the project. So if we take a look here at the service chains tab, here I have some demos already of service chains I've created for this project, but ignore this for now. We have here an example of what it looks like, a service chain. If I open this up on another tab, you can see it's a very, very basic example representation of how this works and how this is visually represented. But say I have a data provider, an infrastructure provider, which can be something like an anonymization service, and then a service provider acting like a data consumer. Well, very easily you can see the flow of data that goes from the data provider to the infrastructure service that does some kind of processing, and then this result of the processing is sent to the final data consumer service provider. So we have this example. If I jump back here, let's do together a process of creating a new chain. So one of the nice things about service chains in their design is that we can make multiple service chains for a single project, which means that we can define several different workflows between the same members of a project based on the needs of the use case. Maybe some specific workflows fit for some partners and some for others, where we can fit all that in a single project. So first step is giving it a name, and this is for categorization for us as a project leader, being able to determine and find quickly the service chains that we've built to avoid having to go and visualize each one every time we want to change something. Just for context here, and to kind of input the demo one. And when we create one, we enter this service chain editor, which can be a little bit overwhelming at first, but it's actually quite simple when you understand the different actions you can do. So if we just take a look around very quickly, so you have at the top here your service chain name that you just gave. You can edit it over here. You have a completion bar, which essentially shows you how ready your service chain is to be used. When it's not at 100%, it means that your chain is not fully valid in technical terms, so it actually cannot be used within a protocol just yet. I heard someone. Is there a question or? No, okay, I'll continue. So if we take a look at the different panels here, on the left side, we have what are available to us inside of our project as the offerings each participant provides to this project. Essentially, what this means is that every participant that I've invited to my project and that has signed the project's agreement makes their offers available for creating service chains. So basically here we have the different participants that we found and the specific offers that they provide to this project. So for example, Games for Citizens here are providing learning records. Prof and Push are also providing learning records. We have service-based offerings and we have infrastructure-based offerings. So that's what we have on the left are the available data that we can work with to create our service chain. And on the right, we have basically the steps in order to go from 0 to a completed service chain by ensuring every validation step is respected. And what's nice about this thing on the right is that it's basically dynamic. So whatever you do inside the editor, it automatically updates the steps. And so you directly know if you've done something that breaks your service chain or not. All right, in the center is basically where you're going to be doing all the work. So if we take a look here at our available resources and we try to build a simple, very simple service chain, it's as simple as taking one and dragging it into the editor. Into the editor, you have some basic controls to be able to zoom in, zoom out, or recenter the view. But essentially, so we start from there, starting from a data provider providing learning records. Let's say, for example, we wanted to go through an anonymization service, and then at the end, being stored inside of a learning record store. This can be a representation of a service chain. However, right now, it's not at all functional because they are not connected together. We can see that on the validation steps on the right. Some of the offers are not connected to each other. And so them not being connected, we don't know the sequence, the actual sequence to run. How do we connect them? Basically through a regular editor workflow. So for visual node flow, so clicking on one of the arrows, dragging it into the input of another node, and basically creating a connection like this. If we continue and finish it up, we have all of our offers that are connected, forming a chain. So we don't need to use every single service, right? We can a service chain can be as simple as having only 2 offerings if that's the workflow needed. But for our demonstration here, let me recreate what I just did. This here forms a valid service chain where data is going out of the data provider providing learning records into the anonymization service, running its process to anonymize the data, and then sending that process results to the learning record store to be able to store the anonymized processed data. So yeah, this is a one of the simple processes and simple examples of a service chain. You can of course through the editor save your work and come back to it later if it's not yet 100% completion. But say you've made this chain and you want to be able to use it, you go ahead and save it. It provides you some technical details. We'll get into that afterwards. And then you can find it in your chains here. This is the one we just created at the bottom. You can go ahead and go back in the editor and edit it if you want, or you can decide to activate it, which will basically inject the service chain representation, the machine representation inside the contract, and mark it as active to be able to use the service chain protocol based on this flow we've just drafted out in the editor. Big thing. So let's go back to the.
Shall we go to the question? We do have a question.
Yeah, sure. Why not?
I'm not sure because this very fancy diagram, it's kind of amazing, but I see several problems or missing pieces, not problems, that are not kind of depicted here. Talking about having data service offering that you connect to an anonymization service, that means I don't know how the probably you do use the Dataspace Connector implementation. You have to move data from a place where the data is, and must have, of course, all the facilities and the connector, then connect it to another infrastructure that has a running services. Hypothetically speaking, this is how I imagine the flow you design with the chain. And then another hope with the latest consumption of the pipe that makes sense. But the point is that this could work if you do have compatibility on those data. So metadata, imagine a real world scenario. You do have an anonymization service that must be configured to understand the format of the data coming. So in a quite simple example, you don't need, if you don't have different metadata or format of data in the data offer, it's easy to design a solution like this. But if you have a variety of data, and that must be interpreted and changing over time, how you will deal with this variety of sources of data to be connected between services and between procedure and analysis procedures that then do modification. The point is that semantically speaking, there must be a certain level of compatibility in order to let the service understand the data and then process in a way that then can be provided to the following hop. How here is foreseen to be done?
Yeah, so this is a good question. And I think a simple answer is to say that it's going to be depending on the evolutions of the available services inside the data space. We have some right now, how it's designed is it's the responsibility for the participants and the participants in the project and in the chains to ensure they work with compatible offerings. The metadata in the catalog, when you're registering your service-based offer or data set or infrastructure offer like the anonymization service, you're going to be defining as informative metadata what kind of input you expect. This is what I'm showing here. Like we know this is going to accept some JSON-based data with an example code snippet of what's expected in inputs. This is really some abstract examples, but just to showcase that we have this information available for project leaders to build their chains and to really be able to check if there is compatibility between the services used, and yeah. So to answer your question again, it is up to the participants to use compatible services in their service chains. They have the helper information to be able to do so. And as the data space grows, there's going to be more services that offer more customization and how they are used to enable more specific and various and a bigger variety of formats of data being transferred.
I will complement something on that. So the question, Pietro, is how will you make everybody interoperable with everybody? And that's a very cool task to have. But so there are different levels. Here we are already facilitated interactions between different participants. There is the first level that Felix said, well, you can see what the others want as input, what the others gives as output, and there it's already better than not having that. And then in Prometheus-X, but that's not the focus of this workshop, but we'll dedicate one to it. There is a component being developed that is called the Edge Translator, and that acts in a sense as this translation middleware using AI and other approaches to be able to translate a given data model into a specific pivot one. And so as a provider, as a user here, you could map your own proprietary model thanks to this component to a pivot one, and then it would do the translation in transit. And so you would have in the service chain this edge translator service that translates and that acts a bit as this translation service between different inputs and outputs.
Yeah, another fact that I'm not sure I understood the diagram. You are putting there providers and consumers. So you already design who is consuming what from whom. So this is kind of something that is not possible to be on demand, because on demand you are not allowed to decide, or you decide when you are selecting some offering in a catalog from whom, and you can be me or you, anybody else as a participant that has the consumer role. So probably the purpose of this chain is to design something for provider and customer that already agreed, but it's the dynamics on that pipes. It's kind of how can be implemented, because if I am
I understand, Pietro, and we need also that we have other questions and so on. So I allow myself to interrupt you. So yes, so if you have already a solution that allows to automatically create dynamic chains and solve all the interoperability problems, please link it. I think here it's the basis of enabling these chains. Once you have this kind of service, a next service on top of that, you could very well imagine some kind of AI agent, some data space assistant that is able to, in a sense, generate and predict this is a good a provider for you, this is a good consumer for you, and automate the creations of these chains. But before we have this automation level, we need to have the first basis of creating and managing the chains. And that's where we're at. Then automating the creations on demand is something you can do only when you have this first basis.
Yes, I get the potential of this supply chain, and it's kind of interesting. I'm of course trying to iterate and to foresee how could be applicable in the scenario that we are facing. So the data space it's composed by participants that dynamically do need to compose bundle and to put in place and not only not the full chain, but simply consumption and adoption of acquiring of infrastructure. And that's why I'm wondering if this static approach could be realized, even due to the fact that there are also constraints on communication between agents, between participants. I guess accessing data should be protected and authorized, like provisioning of infrastructure must be managed in this way. And I get the potential, but I still foresee a lot of detail to be treated, described or faced to create.
I'm not sure. Sorry, Pietro, but again,
thank you.
We need to move a bit forward, and I'm not sure we understand perfectly what you say, because maybe you can precise it in the chat, because when you say, okay, dynamically, what do you mean by dynamically? Is it automatically without human intervention that bundles will be created or not? Can you precise a precise use case, because this is quite general, and so maybe let's, while you precise that, because I think from what I understood from what you just said, it's possible through what we show. So let's maybe you can be a bit more precise in the chat, and let's see, we have some other questions, and then let's move forward.
Right. Next question is Andreas.
Yeah, okay, thanks a lot for this presentation. I would like to clarify, at least for myself, a bit more the status of these infrastructure components, especially looking that you use here an anonymization service as an example. Now, if this infrastructure is not owned in a wider sense by the data provider, then it might be an additional data processing that according to GDPR needs an additional legal ground or a processing contract. Is this infrastructure, is this a software handed over into the domains of the data provider? Is it an independent piece that is owned by another party that can then look into this data? Yeah. What is the exact status of this?
It could be both that you stated. Here in this specific example, we're showing that the anonymization service is held by another participant than the one providing the data. So it's an independent service. As for the legal grounds, there are two of them. If we're talking about non-personal data, there is this project agreement, which is a contract that this project evolves in. So the one I was showing just before, if I go back, this here is the visual representation of the contract.
This is trivial, of course. Yeah, well, more trivial than with personal data, of course. Yeah.
And when you're talking about personal data, where there is all of our components regarding consent management and personal data validation, which come in place and which are based on existing contracts in the Prometheus-X ecosystem. So, for instance, if you wanted to have if I open up this chain again, over here. If I open up this chain again, and if you wanted to have this service chain run on personal data, you would actually need to have the consent of an individual provided on top of this the contract that scopes this service chain. So you would have the rights with the consent to process the data at any point of the nodes here.
But if you have a data set of 100,000 data subjects, no? Then the data provider really needs to get the consent of each of these 100,000 to say, yeah, you can process my data even for anonymization. Also, anonymization is a kind of
Andreas,
processing.
sorry to interrupt, but these are legal questions. That each project should define what is their legal basis. This is not the topic or the scope of what we present. If you have a legal basis of consent, you can have a consent service. If you have another legal basis, then you don't need consent and you can have another legal basis. Doesn't change, I think, much to the flow, except when you have consent, then the consent needs to be checked. Okay.
Okay. Let's discuss it when we meet at some time face to face. Thanks again.
Okay.
So let's move forward now, Felix, with the presentation, and please continue to put your questions in the chat. Of course, all very interesting and relevant, but maybe some will be addressed now, and time is running.
I'll jump a couple slides to go to the most important, but let's take a little bit of a step back to give you some more context about all of this ecosystem and how this works. So the Prometheus-X architecture is composed of several building blocks, some which are considered core, which are the ones that I'm showing here. So a contract service, catalog service, consent service, and a catalog registry. I'll get into most of them afterwards, but these are what we call data intermediaries. And they help deal with all of this control plane layer of the data space and browsing and discovery for the catalogs, the contract verification for the contract base, and the consent lifecycle for the consent parts. One thing to note is that right now the Prometheus-X ecosystem is operating a centralized architecture. But it's we're on our way, like Matthias was showing at the beginning, to implement the Gaia-X digital clearinghouse and migrate to a more federated or decentralized architecture in the future. If we take a look at the current view of the data space for Prometheus-X. So at the center here, you see we have our three core components I just mentioned: the catalog, the contract, the consents. Catalog. We've based ourselves a lot on what is defined in the Gaia-X trust framework. So the definition of participants, service offerings, resources for data, software, etc. These helped us define the shapes and models of how the catalog is represented and kind of makes it so that every participant that comes into the database through the catalog, well, we can ensure that they define their assets in the right way that is pushing towards federation afterwards with Gaia-X services. On the contract section, so we have we're basing ourselves a lot on how ODRL contracts are built. So there are a lot of ODRL policies involved and I'll get into the details of it, but we have two types of contracts. We have the bilateral peer-to-peer contracts, but also what I've just shown with the service chains, these more ecosystem-wide project contracts available inside the ecosystem. Consent part is not our topic today, but so we have a consent management solution, which acts as a personal data intermediary for the individual to interact with the data space. This is based also for the lifecycle and the consent record schemas on a standard. So the ISO standard that came out in August of 2023. And so what's interesting for us then is at the bottom here, each participant, of course, is going to be having to deploy a dataspace connector. Prometheus-X is building its own dataspace connector for a lot of different reasons, but mostly right now what we can say about it is that we needed to define our own because we needed to be able to manage consent, lifecycle and consent management in the workflows, and also the ability to process and communicate with multi-party contracts, which is not something that is handled today in other connectors. And in terms of then the data transfer, it's kind of based on an IDSA database protocol data transfer, but with these extensions and augmentations of workflows links to how consent management and multi-party contracts are used. And also, very important to note, the usage of data intermediaries, which are these services for cataloging, contracting, consents that are maintained by an actor inside of the ecosystem. If we took a look very quickly, just to contextualize what I've shown you before, so VisionsTrust, the tool I was in, is an implementation of these core components in an example of what someone can do to implement these services inside the data space. What we do is take the core components defined of the open source components of Prometheus-X, and then we built a UI on top of it and are maintaining and extending them a little bit to showcase, well, this service chain, for example, with the UI, etc. But it's just an example to show that VisionsTrust is an implementation of these services. So we have this centralized architecture, and each participant has a PDC, which allows the PDC to communicate with the data intermediaries for a lot of different control plane verifications. And of course, the PDC, so Prometheus-X Dataspace Connector, communicates along themselves as well for data requests, sometimes the data flow as well. And so, yeah, the contract service is a contract store and has some negotiation verification mechanisms. The catalog service is what I've shown before, so it has all of these discovery utilities. It's in the Prometheus-X ecosystem where the participant is also going to be onboarded to the data space. And we have this consent service that is more for individual users to interact with the data space, have the space to grant and manage their consents and give their authorizations on how their data is transferred inside the data space. All right. So yeah, I've talked about this before, but Prometheus-X is taking as a basis the Gaia-X Trust framework for defining these participant service offerings and resources, but is also, since we're aiming for federation and interoperability with others, providing some endpoints that allow to have more DCAT representation of the resources, mainly because like the dataspace protocol inside IDS is the catalog protocol defines DCAT messages to be available. So this is one step toward federation and interoperability. It's the ability to have things that are compatible with the Gaia-X services and also things that are compatible with more dataspace protocol-based components and services. I can skip this, actually, I defined it. So very quick word on the catalog registry, which is this fourth component we consider core. It provides a lot of reference models and helpers to facilitate the creation and negotiation processes for participants when they create and register their offers, define the different policies on their offers, defines the business models, pricing information on projects and offers, etc. And one of the most important things that it's used for today is that it holds also ODRL policy template collection, which represents the standard implemented supported ODRL policy verifications inside of the connector directly. This and because it's how we've seen it used inside of our ecosystem, is a very simple way for participants to set some specific access control rules on the access of their data sets and services, which are directly enforced by the connector without them having to go in and define some custom processes for specific ODRL policies. Of course, this is still possible, but it's really a first step to enable participants that have less resources and less needs for very, very specific ODRL policies to get their hands dirty and get into the contract details. As I was saying also earlier, so the projects that you've seen inside VisionsTrust, they're based on this term we pushed inside the DSSC, which is data space use case, which really represents this ecosystem of participants, which is led usually by one of the participants, which is the project orchestrator, coordinating the project, configuring the settings and everything. And we have data providers, service providers, and what we call infrastructure providers, which are also service providers, but usually are aimed to be implementing some kind of data processing service in between inside of the chains. So quick words on contracts. As I said just before, so we have two types of contracts inside Prometheus-X. We have the peer-to-peer contracts, which are the standard contracts. In reality, in our use cases in Prometheus-X right now, it's not the one that's most used. The one that's the most used is the ecosystem contracts, mostly because it enables a wider range of use cases since it encompasses multiple partners around the same use case. But yeah, these ecosystem contracts are the representation of the project and the authorization each members have with their offerings that they provide through this project. The ecosystem contracts and the project definitions, they are based on some work that was done by the C Trouble book to define what are the roles of each partner and member inside of a use case. How do we define the regulations inside, the terms of use, etc. So just as a reference here, this was one of the things that helped us shape how we build our ecosystem contracts today. Now, the workflow, so I've shown it a little bit, but when the orchestrator creates this project, he's then going to be browsing the catalog, finding some different participants and offers that these participants provide, inviting them to the project, enter a negotiation loop to define the pricing terms, the policies, access policies, etc., for their specific offers inside of the context of this specific project. And then the provider is going to be signing the project agreements, making him a member of this project. So the ecosystem contract really encompasses all of this, the information about who is inside, so all the list of members, what different roles and each role has as an obligation, what are the different service offerings inside, so what are the offers provided by the participants inside this project, and this newly added thing that we're presenting today, so the service chains, which is all of this metadata on how these sequences of data operate for a project, which represents the machine readable information for the connector then inside the protocol to be able to read and make the whole service chain protocol run down the line. So inside the catalog registry, I stated that there are a list of policy templates that are the supported list of policies inside the Prometheus-X ecosystem. And how it works is basically that there's a human readable definition of the policy that allows us to make some UI on top of it, like you've seen in the catalog earlier, where we can state that we have no restriction policy or time-based policy or an amount of times usage policy for our specific resource that we're creating in the catalog. And we have in this template a ODRL format, which is going to be post-processed afterwards during the negotiation phase, where the actual values of the rule is going to be defined by the negotiation parties. So, for example, here, it's a little bit more technical, but we have a policy that defines the usage of a specific resource in between two specific dates. These two dates are defined as variables in the template, and during the actual negotiation between the data provider and the data consumer or the project orchestrator, they're going to be defining between when and when this actual resource is going to be available for the context of the contract. Before I get into the service chain protocol, I just want to give an overview on how the data exchange protocol actually works inside Prometheus-X, because the service chain protocol is built on top of it, but a little bit different. So basically, very simply, inside Prometheus-X, the connectors do all of the heavy lifting and provide also an option to make the data transfer go through the PDC itself. So if you take a look here, we have the data consumers connector. It's going to be making a data request, including the contract that they have previously signed on the contract service or the catalog that encompasses the contract service. And since we're working with data intermediaries inside Prometheus-X, the contract service needs to be communicated with in order to verify validity of the contract and retrieve the available policy. So can verify, are the parties really part of the ecosystem? Is it a valid contract? Have they both signed the contract? All kind of different validations before the actual access policy, access control verification is done directly by the connector if the contract is properly validated. Then comes the point where the participants themselves have to do some kind of implementation, because if they decide to use the base, let's say, protocol, which encompasses the data transfer within the data exchange protocol directly, their PDC is going to be calling them to the technical information they registered on their resource to pull the data and then transfer it to the others connector, which is going to push it to whatever service it was agreed to use inside of the contract that is used for the scope of this exchange. So, quick word on the difference between here, the control plane and data plane. As I was saying, the base Prometheus-X data exchange protocol encompasses both and proposes both, like included inside the protocol directly through their connector, which makes it easy for smaller organizations to directly take part of inside the ecosystem and take part in data exchanges, because they don't have to worry too much about handling themselves a data exchange with other participants after doing the control plane verifications. Of course, this can be bypassed. We can have only the control plane run and then have the participants exchange the information based on the success of the control plane verifications. But just to showcase that this is really the base workflow that most partners inside Prometheus-X is using right now. I can skip this right now. So in terms of control plane verifications, we have 3 main points of verification. The last one being optional only if personal data is involved. So the contract validity check works with communicating with the contract manager that is used in the data space. So as I was saying, verifying the contract signature, verifying the contract origin, and a bunch of verifications on the policies that are defined. Then the policy enforcement point, which is located directly inside the connector to verify, well, the authorization on the access of these resources. Again, even though we have this list of supported policies, it's very possible for participants to go and define some more custom ODR policies and extend their connector to be able to process more ODR policies. But in the main usage right now, it's mostly the ones that are supported by Prometheus-X that are used. And if we're talking about personal data, well, consent validity is checked, of course, with the consent service in order to verify identity of the individual, consent validity, and the legal basis of the contract that was used to generate the consent on top of it. So we have all of this ecosystem, and how do we handle more complex workflows? So how do we enable service chains? not going to go read through all of this because it's what we've been talking since the beginning of this presentation. But so service chain, the origin for service chain is for enabling these more complex workflows, bringing some automation capabilities to the data space by enabling these multiple sequences of data transfers, and of course, ideally making it easy and simple for participants to create and use and consume inside of protocols without too much overhead work. So we've seen all of this in the demo, so I'm not gonna go ahead again, but I've shown you a simple use case. There are multiple use cases for service chains. This here is what I like to call a very simple use case where data flows in a single line, which means even though we have 2 or 3 or 10 services, if they go in a single line, it's a very simple representation and it's easy to visualize flow of data. But we also can have some more complicated use cases where additional data can be plugged in and used at certain points of the service chain. Here we have one of these examples where, for example, we have the main data providers providing data to the anonymization service, but before the anonymization service runs, there is actually additional data that should come in from another data source to be processed before the anonymization service runs. And this we can do in the protocol where any number of additional data sources can be added to any points of the service chain if there's a need to have some additional data at some specific steps. Okay, so taking a look very high level right now at how the service chain protocol operates. Here in this image, we're placing ourselves as one of the, for example, the anonymization service. So in between the service chain. How it works is the data provider is going to be sending over the data with the information in the service chain through usually the PDC. The PDC has implementations for the protocol, and it's based on the data processing chain protocol library that Prometheus-X has built for specifically these service chains, and is going to be able to process this information and send it over to the actual resource, so the anonymization service resource of this participant. Is going to be providing the data. It's going to be providing some specific service chain information, because it's up to the participants to basically notify his PDC whenever he's done with processing the data. And the reason we're doing it this way is because we can't know in advance how much time the actual processing of data is going to be taking. It can be a matter of seconds, it can be a matter of days. Since we don't know, we need a way to basically pause, in a way, the protocol and enable participants to resume the process after they're done processing the data. And in very simple fashion, once the data is processed and returned to the PDC, then the PDC, thanks to the protocol, knows with the information inside the contract where it should send the data next, and so it just continues the flow. So this is basically what I've just said, just to reminder that the PDC does basically all of the heavy lifting in terms of automating the sequence by providing the right information based on the service chain to the next connector in the chain, and it's up to the participant to well, basically each participant has a responsibility to implement the protocol and handle the resuming of the chain whenever they're done completing the processing of data, when it's their turn to play on the data. Okay, this is more specific, but so the service chain protocol is available on this newest version that we've released on the PDC. So it's not something that's available for PDCs running an older version. If some of you have used the PDC, then just use this as a side note. And there are some extra implementation required to interact with the service chain, what I was saying earlier, but what I'm going to show here in more details. So very quickly, there are two options to interact with the service chain. The first one is to change the resources servers API. And sorry, we're going to get tiny bit more technical here for a couple seconds, but basically to enable the resource server to send an acknowledgement that they've received the service chain information in the contracts and that they're going to be running the process of the data, and then the ability to send over the notification to their PDC that they're done processing data and that the chain can be resumed. This first option here is pretty fast and simple to implement. However, it requires some more custom processing if the resource server should be used without the service chain as well, because it kind of tightly couples the resource server to work with service chains. But the second option here is adding a layer in between, which is kind of the preferred way to do it, because it's a good separation of concerns. It's more modular, and it makes it more easy to work with, since this layer in between is going to be only handling the interactions with the service chain, and will have the responsibility to pull in the data from the resource server directly. The only downside to this is that it does require the introduction of an additional layer, but by doing it that way, it makes it very modular, and it allows you to reuse this proxy or API gateway with multiple different resources that you have for different service chains that might possibly be of your concern. Very quickly here, this is just to showcase that we've done implementations with a partner of ours that has managed to basically update the connector to the latest version easily and create a service chain and do this additional layer to interact with the service chain in a couple of hours. So proving that it's something that's working fine for them, and in a way that they didn't have to change anything on the core logic of their actual service whenever implementing this solution. So yeah, in terms of resources and documentations, you have a bunch available to you. The PDC has a wiki, which is packed with information on what I've talked about, but also the rest of understanding the data exchange workflows. A lot more information on the actual service chains and the payloads and how the information is transferred, but in a much more technical way. And if you're interested as well, there's a lot of information on the VisionsTrust documentation to understand the tool a little bit better. But yeah, I think this mostly sums it up. I'm going to pass you the floor, Laszlo, for a couple seconds, and then we'll answer all the questions that you might have.
Thank you. So just to give a brief overview on what are those building blocks which can be then used in these different service chains. Basically, there are the core blocks which are supporting the entire data sharing infrastructure, if you want, or the operation of the data intermediary. And there are those which are participating in the concrete data sharing scenarios. There are a number of data transformation building blocks which will offer infrastructure services which will be used in these service chains. Currently, most of these are concretely concentrating on the skills and education, but data transformation blocks available as well. There are a number of blocks which are the kind of utility blocks which help to maintain the quality of the overall operation of the data space, and also to incentivize partners participating and offering their services to these chains. And then there are some which support what we call trustworthy data sharing, for instance, to evaluate the AI models before being used in the data space, to train them in a decentralized way, and also to process the data in a decentralized way. These are a bit more advanced ones, which supports how to build these service chains and support the development also of the services which will be used in these chains, like, for instance, an AI service. I think I will not explain all of these blocks, but I would like to briefly summarize where we are with them in general. So if we can go to the next one, then basically these blocks which were presented or summarized briefly in the slides, these are developed and tested. There we had internal rounds of demos, and then now these are being integrated to be part of these chains. These blocks will offer different infrastructure services. So these will appear in the VisionsTrust catalog as kind of infrastructure service providers, just as in the example of what Felix shows. And also the building blocks themselves actually the code which is running and providing this service will be available as open source. So we are now in the finish of finalizing these individual blocks, but for them there are some already available resources. Like, for instance, we have a white paper on the overall approach summarizing some of the key aspects and some of the main functionalities of these building blocks. We also have a detailed technical documentation for all of these, including their design and the high-level scenarios of their operation, which help you to understand what is the functionality of these blocks, which then can be combined into different chains. And then these blocks and more precisely the infrastructure services provided on top of these blocks will be soon available in the VisionsTrust catalog. So if you want to see more details, then you can check both the design of these blocks and then also the concrete offerings in the catalog. And there are also some additional presentation materials to come soon, like, for instance, instructions and short videos summarizing the functionalities of these individual blocks, if you like these individual Lego bricks, which then you can combine. So now I'd like to pass the floor to Matthias and Felix, and then I think we should concentrate on the questions and answers.
Yes, I think we can focus on the questions now. If there are any, please feel free to raise your hand and ask them.
Yeah, I answered, I think, most of them. But if you're not satisfied with my answer, please tell us if something's not clear.
We have a question from Eric.
Yes, sorry I didn't put it in chat yet. So first, I really appreciate what you're doing here. And a question, I've got, I guess, several questions, but one question is how this, I mean, it's kind of, even though what you're talking about as complex workflows regarding the way of defining this, it's still pretty simple workflows. So my question is, could it be extended to the really complex workflows in general, like at least one way of doing that would be with BPMN, so business process modeling and notation, where you have like support for defining any kind of workflows within a company or between enterprises, whatever, and letting that be the, let's say, definition of the contract as an alternative to what you're doing here. In my mind, it's like you could use the same concept for choreographing the project and so on. Is that something you could go into now, or we could save it to an offline session?
Well, sorry, Matthias, go ahead.
Yeah, I think Laszlo, go ahead.
Just for the BPMN part, we were checking the opportunity of using that. But I think currently, if you consider that these things here are mostly cross-organizational data sharing workflows, I mean, most of the steps, this will, in let's say, for the practical first use cases, the complexity would not be, I think, that much on the workflow control and structure than the definition of the dependencies and the data types. So I think it might be a later step, but to start, I think what's shown with Felix can cover most of the practical use cases of workflows. Felix, please. Just you were going.
Yeah, no, I think what you said is correct. Most of the workflows is in fact possible with what we've shown. There are some limitations right now. If for example you want to plug in the result of a service chain inside of another service chain, this is going to be a little bit complex right now. But you have this ability to plug in, for now, additional data sources at several points of the chain. So it already enables some a little bit more complex workflows, but for really more complex workflows, so service chains within service chains within service chains, this is something we're thinking about, but much more complicated to wrap our hands around right now.
Yeah, that's okay. So there's something to develop, I guess, and also the concepts for like event-driven architectures with known or unknown participants, as opposed to the known participants and on-the-fly contracts and so on. But I mean, yeah, what you're doing so far is really, really interesting and a very good start.
That's indeed the next step. You're right. How can we automate contracts and this kind of generations? So yes, we're working on what is called a consent and contract agent that can provide some automation that you don't need to each time renegotiate and validate stuff, and that can then be plugged as well to then generate contracts, and from these contracts generate chains. So that's a bit the next step. But as I was saying to Pietro, we need this first layer before we get into this more automated layer. Any other questions? Pietro, did that answer your concerns or questions? If you're still here?
Yeah, I'm still here. I kind of concerned about, as you surely know, interaction with the control between participants, and the approach of having a centralized orchestrator like this will add a lot of issues or things to handle in terms of authorizing the orchestrator to deal with the resources of other providers. So an orchestrator that have to instantiate our infrastructure data and put it all together. It's of course amazing from a certain point of view. Pipeline chains of value added. It's something we aim to provide, but also contracts. And when you are providing something, resources and costs and permissions come in place, and an orchestrator that do the job must have full control of all those resources. And I don't really think it's easy to put in place this approach. So that is my personal opinion, of course.
No, I think so. There are different things. So you say that we provide, just to know, is it from Aruba's or from Simple side that you mean?
No, I'm thinking about a generalized even Gaia X approach that has participants, single participants that deal with, that provide service offering to be consumed, to be combined, to be chained. But then every single resources need to be contracted with the contract negotiation protocol. Indeed, it's something that Dataspace that come in place to fulfill the individual provisioning of those. So the orchestrator must also have to deal with the handshaking with the Dataspace protocol and the contract negotiation for every single resource, service, or data that it orchestrates. The approach you shown, it's kind of okay. No, it's good. I'm finished. I'm just finishing. The orchestrator you have seems to have the full control of all the resources and doesn't deal with any negotiation or with participants.
No. We use orchestrator differently. So when I answer, I think what you mean by orchestrator is, for instance, here the VisionsTrust tool, right? That is this kind of intermediary between everybody. Is that what you mean by orchestrator?
The building block that Felix shown. Okay. So it's called orchestrator. That is the engine, I suppose. They do the magic of connecting connectors and do the connection between sequences of chain.
It can be called an orchestrator indeed. When I answered your question, what we call orchestrator is the organization, so a participant in the data space wanting to bundle up some of their offers with others, and that has the lead in a sense of designing that bundle and that chain. And so in that sense, this participant, yes, you have contracts with the 2, 3, 4, 5 other participants to enable the chain. The service chain operator, what we call the data intermediary in the middle, doesn't need to have this full control or full access to everybody.
I need to see a concrete and real implementation how this will deal with the access policies on activating a provisioning of anything, data or infrastructure, because in real world scenario, before an infrastructure provider will give you resources, need to be fulfilled in a contract, need to negotiate in the dataspace contract. Dataspace protocol means has a dedicated contract negotiation protocol for doing that.
Yes.
So any of the hope you are designing needs to be dealing with this.
Indeed, but maybe you missed a part of the presentation, but that's what Felix showed. There is a negotiation and a contract, and it's checked during the interactions by the connector. So we don't have time to re-explain it, but of course, that's the whole concept of a data space. And there is a contract, there are policies, each provider has defined that, and then those are checked and enforced during the chain.
Okay.
I see other hands. Yes, Johannes.
Yes, a very simple basic question. What the simple workflow that Felix has shown with the 3 nodes. So this is a specification of a transformation, right? And is this just the specification that you are demoing today, or is it actually executable? So you have some actual input data, you anonymize it, and then you store it in Kofu.
So the use case
because we have not seen, I mean, the actual, let's say, result of this, workflow.
Felix, I think you can demonstrate a chain, but so this use case of anonymization and then in Okufu and the different providers is an actual use case of the data space. And so the different participants have implemented it. Indeed, today it was more about showing the kind of core engine and how that works. This is one example. We'll have we can organize a specific meeting, Johannes, if you want. It's working now, and we'll have a public event in June to show actual use cases on top of that.
Okay. Thanks. I mean, I was just in this, let's say, gray area, if this is just a specification or it's an implementation aspect. Because if it's an implementation, I was really, astonished, because when you say anonymization service, what does it anonymize? How does it select what it anonymizes? What is the outcome?
You're right.
So, I mean, in front of talking about, let's say, legal or contractual or governance aspects, we need to see something actually working, and maybe later you can delve into the non-technical, let's say, aspects, but you need to impress, to showcase the actual result first, I think.
Yes, so Johannes, there are different things. Here, what we wanted to showcase is the ability to combine different providers together in a chain, and that is implemented and working. Then you have it in the middle. It can be an interoperability or an anonymization service or any kind of other service. The specifications of those services, you can find them on the catalog. We'll have some specific demos on it, but it was not the point to dive into the specifics of one particular chain or one particular infrastructure service, but to show the capacity of chaining them together. Then you can choose your preferred anonymization service. It's a bit out of the kind of scope, in a sense, of what we wanted to show. the point here was to say most of dataspace implementations today are sharing data from A to B. Here we have a way of managing the chains. Then the nodes of this chain, it's up to each dataspace. And again, we'll have some skill-specific chains to be demonstrated in June. And you can already find on the catalog the anonymization services that are available.
Okay, thanks.
So yes, Avasilkai.
Just Ovidio. I was looking at the connector implementation, and the data plane doesn't seem to like it's there's no separation between the data plane and like the control plane. It's all in one. There's no way to add a separate data plane.
Yeah, so quick answer to this. The initial implementation of the PDC was aimed to participants that had the need to have data transfer incorporated inside the connector, which is why the protocol has this incorporated inside it. You could perfectly well, through this protocol, exchange only some control plane data authorization and request endpoints for participants to then run the concrete data transfers on their own afterwards, but that would remain scoped to a PTX workflow. In that regard, this is why we have implemented the basics of the DSP protocol as an additional protocol, even though it's not right now yet tightly coupled with the Prometheus-X workflow. But this is why we're also looking towards working with all of these other these other database initiatives and the interoperability questions to enable these concepts that are more used by other connectors today.
Wouldn't that complicate things? Because right now the scenario for the orchestrator then in this case seems very simple. It handles a certain data type. It doesn't go with the complexity of different resource types, different transfer types, that then different connector types, sharing of these data planes. I'm sorry, I'm not sure if I'm expressing myself correctly.
No, but it's a very valid question, and one I'm asking myself a lot lately. But there is no yet a perfect solution to make everything work together and have various data planes work with every kind of workflow inside Prometheus-X or any other connector out there. So it's something that I think a lot of people are looking into, and so as we, in order to find solutions that enable us to make this protocol work with our workflow, the Prometheus-X workflow, but also with other data planes that are supported in other connectors. Of course, it's going to be augmenting the complexity, but I don't think we have any easy solution for this anyways.
Okay, we're out of time. If somebody has another question, please go ahead.
One question is about the, let's say, automatic, I put it in the chat. So a couple of questions, but one about data provenance and also compliance. Now, according to your ecosystem contract, there's two questions in one maybe, but it's got to do about tracking and logging and so on to see that everybody performs according to the contract. Data provenance, which data came from, where became into what.
So this is indeed monitored and logged, if that's the question.
And is it also shown, like you could show how the service chain has been run?
Yes, you can, as a participant of a chain, you have that information to see when a given, in a sense, sequence was executed, each node, if it had, or if there was a failure.
Okay, thanks.
Okay, thanks everybody then for your good inputs and questions. Indeed, these workshops also serves to get a bit the different needs. So from what I understood, it's mostly about how do we automate this kind of contract and chain generation. That's on the roadmap as well, but that was the first step. And don't hesitate to look at the code, the documentation, do so many kind of pull requests and so on, or write to us or test it yourselves, or contact us if you want to have some sandbox environment. And yeah, have a great evening.
Bye.
Thank you. Bye.